Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 3.4, which is going to do with graphing functions. So for today's lesson, we have two learning goals to take a look at. Our first learning goal is you will be able to graph a function on the coordinate plane, and you will be able to find the value of the function given a value for x. So they'll tell you x equals 3, what is the value of the function? And we'll talk about how we can figure that out today. All right. Now, before we jump into our first example, one thing I just want to quickly note. Section 3.4 is the end of Module 3, which means that you should have a quiz upcoming here soon. So be on the lookout for that as we move forward throughout today and in the future. So 3.4, graphing functions. Today we're going to graph lines or quadratics just based off of whatever function they give us. Sometimes they'll give us a domain and we'll plug that in to figure out what we need to graph. Sometimes they do not provide us a domain and we have to figure that out. So example 1 is going to ask us to fill in the table and graph each function. So I'm going to move this up so we can just focus on our problem. So, for example 1a, we have y equals negative 3x plus 2, and they give me a domain of negative 1, 0, 1, and 2. So the question asks us to fill in the table and then graph each function. So I need to fill this table in using my domain and the function they give me, and then we will go through and graph it. So, first step, if they provide me a domain, remember domain is the x values, so I'm going to plug those in. So we'll have negative 1, 0, 1, and 2. If those are my x values, I then can take these values, negative 1, 0, 1, and 2, and I can plug them in for x in this equation here. So my equation is y equals negative 3x plus 2. I need to figure out the output, the y values, based off of knowing my input, my x values. Now, you can do this on a piece of paper and you can write and solve these all out through. You can use a calculator or Google ways to go through and solve a table for the function. I'm going to use the calculator. So my equation is negative 3x plus 2. So we're going to start out with negative 3. What I'm going to do is plug these values in for x one at a time. So we're going to do parentheses, negative 1, end parentheses, and then I have plus 2. So we're going to plug all these values in for x, like we did with section 3.3 when we took our reasonable domain to figure out our reasonable range. So we're going to plug in all the domain values to figure out what we get. Now, our first one here, when I plug in negative 1, we get 5. So that means my y value is going to be 5. And then we're just going to keep doing that throughout the rest of the table. So we're going to keep the same equation, and we're going to go in and use 0, and I'm going to get rid of that negative. So when I plug in 0, if we do negative 3 times 0 plus 2, we get 2. And if I continue to go through and do that, if I plug in 1 and 2, I'm going to get negative 1 and negative 4. Just to kind of prove that that is the case. So when I plug in 1, I get negative 1. And when I plug in 2, I end up with negative 4. So I have filled in my table. So that was the first part it asked me. The second part asked me to go through and graph the function. So we are going to go through and plot these points. Unlike section 3.2, where we just plotted the points and that was it, because I have an equation, and they've given me this equation and not just a relation, we are going to connect them and form a line or a quadratic. Just depends on what our equation is. So this is a line. So let's first go through and plot our points. So negative 1, 5, 0, 2, 1, negative 1, And then we have 2 comma negative 4. So then that's going to be our point right there. All right, so I have gone through and plotted all the points. So to finish my graph for this function, you're just going to take your ruler and we're going to go through and connect our points. And I end up with my graph like that. So that is example 1A. I've gone through and filled in my table using the function in the given domain. And then I went through and used my table to graph my function for y equals negative 3x plus 2. All right, so for the rest of this, for example 1, for parts A, B, C, and D, it's just more graphing and filling in the table. Part B is the same thing we just did, it's just the function looks a little different. Okay, so I know my domain is negative 2, 0, 2, and 4. So those are my values for x, so that's what I'm going to plug in for x. And then my y values is what we're going to go through and solve. Now, this one is a little bit different. Unfortunately, it's not just plugging it in and then you can plug it into your calculator and solve, because we have x and y on the same side. So there's 2 ways we can go through and do this. First way is I can go through and take all these values, plug it in for x, and then by hand solve for y. Or I could solve my equation for y, and then I could go through and plug this stuff in for x and use your calculator. Doesn't matter on how you would like to do this. For the first point, I'm going to go through and show you how you set it up, and then I'll go through and show you how we can do this a little bit more quicker. So the first way we can do this, and I'm going to pull out another piece of paper to set up. So we have x plus 2y equals 8. So that's going to be my starting point. My first value for x is negative 2. So I'm going to plug negative 2 in for x. And what I need to do from there is just go through and solve for y. So you're just going to use your algebra solving skills from here. So if I have negative 2 plus 2y equals 8, I need to get rid of this negative 2 because it's negative. I'm going to do the opposite, which is to add. So if I add 2 to both sides, cancels out on the left, and then I get 2y equals 8 plus 2 is 10. And then if I have 2y equals 10, if I divide by 2, 2's cancel on the left, and I get y equals 5. So I now have y equals 5, which means when x is negative 2, y is 5. So you can go through and fill in the rest of the points by doing that. Another way is I can take this equation and I could solve it for y. So if you feel comfortable going through and plugging in the points, so I'd plug 0 in for x, and then you continue to solve, by all means you can do that. Okay? If you want a bit different way, like we did with example 1 where we just took this equation, you would have to solve this equation for y first. So before I do that, I do want to run through at least one more with plugging in, and then I will take a look at how we go through and solve an equation for y. All right, so our next one. Again, we have this x plus 2y equals 8. So this is going to be my starting point. And I want to figure out when x is 0, what does y equal? So let's plug 0 in for x. So it's 0 plus 2y equals 8. If we do 0 plus 2y, we can really just cancel out the 0. So I have 2y equals 8. And to solve this, we need to go through and divide 2 to both sides. So the 2's cancel on the left. And then I end up with y equals 8 divided by 2 is 4. So we get y to equal 4. So that means when x is 0, y is 4. So that is a way that you can go through and do that. You can finish that off for points 2 and 4. The other way that I've alluded to is going through and solving this equation for y first, and then you can plug stuff in. So let's go ahead and take a look at doing that. So if we start with x plus 2y equals 8, to solve for y, okay, think back to section 2.3 when we solved for a variable. Okay, I need to move this x over here. So it cancels on the left, and we get 2y equals 8 minus x. And then I need to get the 2 away from the y, so I'm going to divide. And we get our equation to be y equals 8 minus x over 2. So this is going to be my equation for y equals. So from here, all I need to do then is take 2 and 4 and plug it in for x. So that means we're going to do 8 minus 2, 8 minus 4, and divide those by 2. So at this point, we can take our calculator and go through and solve for this. And trying to split the difference so we have room to see all parts. Okay. So to do this, we're going to set this up, the top part, this 8 minus x, we're going to set in parentheses. So we're going to have 8 minus 2. And we're going to, oh, I didn't do minus. So we're going to do 8 minus 2. There we go. Close the parenthesis, and then it's divide by 2. So we're going to divide by 2. And then I get my value of 3. So when x is 2, y is 3. And then I just need to go through and check for 4. So 8 minus 4, divide by 2. That is going to give me 2 as my answer. Now, if you want to, we can go back and check what we got for -2 and 0. I'll just check 0 real quick. So if I type in 0, I do get 4, and that matches what I have there. So that's going through and doing that a couple different ways. You can either just plug these in for x and then go through and solve, or we can solve the equation for y, and then you can plug in all the x values. All right, so I now have all of my points. So we're going to go through and plot my points then. So we have -2, 5, 2, 5. We have 0, 4. We have 2, 3. And then we have 4, 2. So I now have my points based off my table. We're then going to use those points and use our ruler to connect and draw our line. So once we do that, I then get my line to look like such. So that is our answer for example 2b. That is filling in the table and then going through and graphing the line. All right, so continuing on, example 1c and d are going to have us continuing the same thing where they want us to fill in the table and then go through and graph the function. Now, if you notice with parts C and D, they do not provide us with a domain. So that means we need to go through and discover what our domain is, or choose a domain, doesn't matter, and then go through and graph our functions. Now, if we look at C, we have f of x equals x to the power of 2. Remember, treat f of x as like a fancy y, so it would be x comma y or x comma f of x. Now, x to the power of 2 is considered a quadratic, so it's going to be a different graph than just a straight line. Anytime you have something to the power of 2, you kind of want to go through and choose a range of numbers. I'm going to use -2, -1, 0, 1, and 2. I'm going to add one more than what they give me. And we're going to go through and plug these in. One thing I want to caution you with is when you go through and have anything to the power of 2, okay, you have to be really careful. So if I just did -2 to the power of 2, okay, I get -4. -4 is not correct. Anytime you're dealing with putting something to the power of 2, you need to put it in parentheses before you put it to the power of 2. So we're going to have parentheses -2 to the power of 2, and we get 4, which is our correct answer. So when x is -2, f of x is 4. When x is -1 to the power of 2, it's 1. And then if you're dealing with positive numbers, you don't have to worry about putting in parentheses. So I can do 0 to the power of 2, I get 0. 1 to the power of 2, I get 1. 2 to the power of 2, I get 4. So that means I'm going to have 0, 1, and 4. And you can kind of see with the pattern of 4, 1, 0, 1, 4, why I chose more than just 4 numbers for this. So if we go through and plot our points, -2 is at 4, -1 is at 1, 0 is at 0, 1 is at 1, and 2 is at 4. So anytime that you have x to the power of 2 in your function, okay, it's going to form a U shape, which we call a parabola, and it's not going to be like connecting lines just for a straight line, but our graph is going to look like that. Now we're not going to get into anything too much more than that, but I just want you to know that's how we fill in a table, how we plot the points, and what the graph looks like for something with x to the power of 2. All right, now D is f of x equals 2x minus 2. Again, there's no domain, so you just really have to come up with your own domain. It does not matter. You can use 0, 1, 2, 3 if you like. You can use -1, 0, 1, 2, whatever numbers you want to choose. I just suggest you make it simple. I would suggest you use -1, 0, 1, and 2. I will leave this one for you to go through and plug the numbers in to figure out your f of x values, and then to go through and graph the line. So I will leave that for you to do. If you have questions, just ask me next time you see me, or you can take a look at my completed notes for some guidance. All right, so example 1 is the bulk of what we're going to be doing for today's lesson. Now, example 2 asks us to go through and to find the value of f of x when x equals -2. So we need to figure out what the value of these are when x equals -2. Now, you can use a graph to locate the value, and after I've finished going through and solving these, I'll talk about an example and a way to do that based off a graph. But while you can use the graph to locate the value, okay, I want to show you a way without using a graph to go through and find the value. So it wants us to figure out the value of f of x when x is -2. That means all I really need to do is take that value for x, which is -2, and plug it in for x in both of these functions to solve for a and then to solve for b. So if I do that, for a we have f of x equals -1/2 x plus 3, and I'm going to plug -2 in for x. So -2 goes in for x. So I have -1/2 times -2 plus 3. So what I'm going to do is take my calculator, and I'm going to take -1/2. So again, I'm going to do -1 divided by 2 in parentheses. Then we're going to multiply this by -2, and then plus 3. And then when I hit enter, we end up with 4 as our value for the function. So when x equals -2, f of x is going to equal 4. And that's my answer for A. So sometimes they're going to ask you to go through and locate it off of a graph, but as long as you have your function, you can then go through and take the value for x and just plug it in. So you don't always have to go and look at a graph to figure it out. You can also go through and just plug it into the function. So let's do one more of those, then I'll talk about how to locate off a graph. So for B, we have f of x equals 3/2 x minus 4. So again, we're going to take -2 and plug it in for x. So we have f of -2 equals 3/2 times -2 minus 4. So we're going to go through and plug that in to our calculator. So parentheses, 3 divided by 2 times a -2 minus 4. We end up with -7. So when x equals -2 for this function, f of x is going to equal -7. And that is how you go through and do example 2. So if they ask you to find the value of f of x when x equals something for the function, okay, sometimes they'll ask you to locate it off a graph. And I'm going to show you how to do that in a second. If you prefer to not have to graph it, you can just plug this value for x in and then go through and simplify. Now, if I were to ask you to go through and find the value of x based off a graph, let's look at our graphs for A and B. A or B, it doesn't matter. Let's take a look at B. So let's say I want to know the value of this function when x equals, let's go with 1. So let's say I want to know the value of this function when x equals 1. And let's say I want you to do it from a graph. So what you're going to do is go on the x-axis, you're going to locate 1, so 1, and then you're going to go up until you hit the graph, and then the point in which you hit the graph at 1 is then going to be your point, and then we just go over to the y from that point, and then that's the value of our function. So in this case, when I go to 1, okay, my graph hits here, which is at 3.5. So the value of this case when x is 1, f of 1 would equal 3.5. So for these, when they ask you when x equals -2, what does f of x equal? All that means is that how you do it off the graph is you go to -2, up to the graph, and then where it crosses at y. And that's what it's looking for. So you can either go off of a graph if you want to graph it, or you can just plug in the values and figure it out. All right, so that is example 2, parts A and B, and this really should be labeled 3, but part B is going to ask you to do the same thing, to use a graph to find the value of f of x when x equals 3 for the function f of x equals -x plus 7. So you can go through and graph this if you would like. So if you went through and graphed it, I'm going to go through and show you real quick. This is what our graph would look like. So I chose the points -1, 0, 1, and 2. And when I plugged these points in for x here, okay, I got 8, 7, 6, and 5. So I plotted my points, graphed my line, and I want to know what the value of f of x is when x equals 3. So I go over to 3, up to the graph, and when x is 3, my graph crosses at 4. So when f of 3 equals 4, so when x equals 3, my value is going to be 4. So I go over to 3 and then up, and it crosses at 4. Okay, so moving on then to example 3. Now, example 3 is going to be some story problems for us. For 3A, we have the Mid-Atlantic Ridge separates the North and South American plates from the Eurasian and African plates. Doesn't really matter. The function y equals 2x or 2.5x relates to the number of centimeters y, the Mid-Atlantic Ridge, spreads after x years. Graph the function and use the graph to estimate how many centimeters the Mid-Atlantic Ridge spreads in 4.5 years. So I'm going to show you how to do this fully drawn out, and then I'll kind of talk about how you can solve this without having to go through every step. So first and foremost, really just ignore everything I read. Find your function, which is y equals 2.5x. So that is what we're going to go through and graph and set up our table with. Now, it doesn't matter what numbers you use for x. I'm just going to use 0, 1, 2, and 3 because they are great points to plot. So we're going to take 0, 1, 2, and 3 and plug it in for x. So let's go through and fill in our table before we graph. So we're going to have 2.5 times 0, and we get 0. And if we take 1, we do 2.5 times 1, and we get 2.5. If I take 2.5 and times it by 2, I get 5. And then if I take 2.5 and times it by 3, I end up with 7.5. So I've gone through and filled in my table for my function y equals 2.5x. Now we're going to go through and graph it. So when x is 0, y is 0. When x is 1, it's at 2.5. 2 is going to be at 5. And then 3 is going to be at 7.5. All right, so I now have my points plotted. I'm going to go through and draw my line. And that represents my function of y equals 2.5x, which relates to the number of centimeters the ridge spreads after a certain amount of years. So as the years go on, the ridge spreads further and further apart. All right, now I am not completely done because it asked me to figure out how many centimeters it spreads in 4.5 years. So that means I'm going to go to 4.5, which is here on the x-axis, and I'm just going to go up to where it hits on my graph, which is right about there. And then we just want to see where that point is on the y-axis. So it crosses there in between 12 and 10. So I would say it's feasible to say about 11 centimeters. So that is my rough approximation. If you want the actual precise amount for this, it is going to be 11.25 centimeters. And I'm going to show you how we go through and figure out the precise one with our next example. All right, so that is example 3A. And then our last one for today is going to be example 3B. So let's go ahead and cover this up. So example 3B states a cruise ship is currently 5 kilometers away from its port and is traveling away from the port at 15 kilometers per hour. The function, this is the part I want to highlight, y equals 15x plus 5 relates to the number of kilometers y the ship will be from its port x hours from now. How far will the cruise ship be from its port 2.5 hours from now. Now, real quick, if the problem asks you to go through and fill in a table and then graph it, you would take this function, you would use numbers like 0, 1, 2, and 3, plug it into your function, find your y values, and then graph it. If it does not ask you to graph, okay, I'm going to save you time from actually needing to go through and plug stuff into the table and then graph it. So the way to kind of expedite this process, because I know not a lot of you are going to enjoy graphing, if you want to do this without graphing, we take our function, y equals 15x plus 5. They want to know, really the ultimate answer is how far the cruise ship will be after 2.5 hours. So what you're going to do is take that 2.5 and plug it in for x. So we're going to have y equals 15 times 2.5 plus 5. So we'll just go through and type that into our calculator. So 15 times 2.5 plus 5, and we end up with 42.5 kilometers. And that is how far away the cruise ship is. This is a more exact, precise answer than necessarily going off the graph. And to kind of reference back to example 3a, okay, the way that I got this 11.25, my precise answer, is I took my function y equals 2.5x and I plugged 4.5 in for x. So that means all I did was take 2.5 and times it by 4.5, and that's how I get 11.25. So when you get to the story problem ones in the homework, okay, it may talk about graphing or using a table or whatever. It does not actually ask you to graph or make you graph. There's no sense in actually needing to graph. What you can do is, like I did with example 3b, take your function that they give you for the situation, so this y equals 15x plus 5, plug in what they want you to go through and figure out how far away it is or whatever, in this case 2.5, plug it in and simplify. So this is a way without having to fill in a table and graph in finding out your answer. So with that said, that is your lesson for section 3.4 on graphing functions. If you have any questions, as always, next time you see me, be sure to ask or shoot me an email. Be sure to look at my completed notes for some further work done. And that is it for 3.4 on graphing functions. Thank you guys for listening, and let me know if you have any questions. So have a great day, and I'll talk to you guys later. All right, bye.